Explorer 1 and Explorer 2 were phenomenal space contraptions, a long way from being standard models. They were fastidiously planned, areas of strength for width, and a rotational speed extensively slower than the hour hand of a clock. On various occasions, this design feature reduced apparent obscuring, allowing the rocket to capture both pictures and information simultaneously as they crossed the vastness of space. Even before their missions took them to the outer planets, their wonderful imaging technology had already begun to impress both scientists and the public. The spacecraft began transmitting pictures of Jupiter months before finishing their primary objectives. These early pictures, showing swirling clouds and the Great Red Spot, captivated crowds at NASA's Jet Propulsion Lab. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly captured everyone's attention. Slightly larger than Earth's moon, Io turned out to be the most volcanically active body in the entire solar system. The spacecraft's instruments detected continuous volcanic activity, confirmed by dynamic pictures showing towering eruptions and a surface marked by volcanic deposits. One of Io's most prominent volcanoes, Pele, erupted with a force typically greater than that of Mount Everest, covering an area almost the size of France. Eventually, as the spacecraft's cameras shut down to conserve energy and memory before their journey into interstellar space, it is important to note that the photos they captured did not include Mercury or Mars, due to multiple factors. Despite this, NASA continued to develop other remarkable spacecraft, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 1 surpassed Pioneer 10, marking the moment when Pioneer 10 was overtaken as the farthest spacecraft. Pioneer 1 continued its solitary journey for an additional 14 years, finally entering the interstellar medium on August 25, 2012. Although there were no major space missions in the years that followed, NASA didn't publicly announce this significant milestone until 2013. Meanwhile, the S8 tension arose due to gravitational lensing studies, which suggested a lower-than-expected value for S8 based on cosmic microwave background (CMB) data. Research aimed at resolving the S8 discrepancy has led scientists to explore various hypotheses, ranging from potential data errors to fundamental changes in our understanding of gravity. Contemporary simulations, like the Flamingo project, have been instrumental in providing insights into the complex interaction between dark matter and gravitational forces in shaping the cosmic web. Despite the challenges posed by the S8 tension, many measurements at low redshifts and from the CMB remain consistent with the standard cosmological model. This has led to exciting theories that the universe might have undergone significant changes, pushing us to reconsider our current ideas about the large-scale structure and evolution of the universe. In short, the S8 tension presents a major challenge to our understanding of cosmological patterns and may require updates to our current theoretical frameworks. Explorer 1 continues its remarkable journey, faithfully transmitting priceless data from the farthest reaches of the universe for almost 50 years. This extraordinary spacecraft has greatly expanded our understanding of space. However, recently, Explorer 1 has started transmitting unusual data back to Earth, leaving the entire space agency stunned. Are these disturbing signals merely the result of a glitch, or could they be messages from extraterrestrial sources? Join us as we explore the truth behind these extraordinary transmissions. For years, scientists have been fascinated by the mysteries that lie beyond our planetary boundaries. This curiosity led to the historic launch of Explorer 1 and Explorer 2, among other esteemed space missions. These groundbreaking missions, celebrated for their scientific achievements, began with the launch of Explorer 2 from NASA's Kennedy Space Center on August 20, 1977. A few months later, on September 5, 1977, Explorer 1 was launched. Each of these twin spacecraft, weighing roughly 711 kilograms, about the size of a small car, was sent into space during a specific planetary alignment, marking the beginning of their incredible journeys. The explorers traveled at different speeds, culminating in a pivotal moment on December 15, 1977, when Explorer 1 surpassed its twin. Since then, Explorer 1 has evolved into an invaluable scientific instrument, providing vast amounts of data and unraveling the secrets of space. Before diving into Explorer 1's most recent stunning discovery, which has stunned the entire space agency, let's first revisit its remarkable contributions, especially its Jovian imaging mission in 1978. At that time, Explorer 1 was positioned 265 million kilometers from Earth. From this vantage point, it began transmitting a wealth of pictures. In January 1979, the spacecraft embarked on a 100-hour mission, capturing time-lapse photos of Jupiter's atmosphere. This treasure trove of 3,750 pictures allowed scientists to observe Jupiter's dynamic weather conditions in great detail. Soon after, Explorer 1 made its way through Jupiter's moon system, leading to a pivotal discovery: a faint ring around Jupiter and two new moons, Thebe and Métis. These findings expanded our understanding of Jupiter's complex atmosphere. To ensure a safe trajectory and avoid a potential collision with Titan, one of Saturn's moons, the spacecraft executed precise maneuvers. Explorer 1 then continued its journey toward Saturn, where it discovered 4 additional moons: Mimas, Enceladus, Tethys, and Rhea. After completing its Saturn mission, researchers decided to end the planetary objectives of the Explorer mission and directed both Explorer 1 and Explorer 2 past the Sun's influence, speeding through space at an astonishing pace of 325 million miles per year. In January 1990, a new phase began: the Explorer interstellar mission. During this period, Explorer 1 captured some of the most iconic images in history, preserving the legacy of the planetary system. One key figure in extending the mission's objectives was the renowned astronomer Carl Sagan. As a member of the Explorer imaging team, Sagan strongly advocated for one final set of pictures as a memento for humanity. His dedicated efforts paid off on February 14, 1990, when Explorer 1, positioned 6 billion kilometers from Earth, captured the famous pale blue dot image, an awe-inspiring photograph of our planet, appearing as a tiny speck in the vastness of space. These stunning images, totaling 60, became part of the spacecraft's remarkable collection of 670 photos taken during its encounter with Neptune. Meanwhile, Explorer 2 achieved a remarkable feat by recording wind speeds exceeding 1,000 meters per second, the highest ever observed in the local solar system, while it ventured 298 kilometers into Neptune's methane atmosphere. This provided invaluable insights into the distant planet. Neptune's largest moon, Triton, was identified as one of the coldest locations in the solar system, with surface temperatures plummeting to extreme lows. Triton also displayed unique features, such as nitrogen gas geysers and ice volcanoes ejecting debris up to 5 miles into its thin atmosphere. These astonishing discoveries deepened our understanding of the diverse and complex celestial bodies that populate the outer reaches of our solar system. A mysterious new discovery has recently emerged. Before delving into this new unsettling finding, Explorer 2, in particular, achieved several history-making milestones during its journey. In 1986, it became the first spacecraft to fly by Uranus. In 1989, it performed a flyby of Neptune, becoming the first spacecraft to do so. As the Explorer spacecraft continued their missions, NASA implemented various strategies to extend their operational lifetimes. Over the years, certain components and heaters were deactivated to conserve power, ensuring these remarkable pioneers could continue operating well into the next decade. The projected mission end date is currently set for 2030. For the scientists and engineers involved from the very beginning, the Explorer missions represent both a tremendous source of pride and a wave of nostalgia. Their passionate efforts have far exceeded expectations, and the wealth of data provided by the spacecraft has led to countless scientific discoveries, inspiring both researchers and space enthusiasts alike. In the end, Explorer 1 and Explorer 2 were not just ordinary spacecraft. They were the result of meticulous planning, rigorous design, and rotational speed much slower than the hour hand of a clock. This innovative engineering minimized apparent obscuring, allowing the spacecraft to capture simultaneous images and data as they traveled through space. Even before their encounters with the outer planets, their impressive imaging capabilities began to captivate both scientists and the public. The Explorer spacecraft began transmitting pictures of Jupiter long before completing their primary missions. These early pictures, showing swirling clouds and the famous Great Red Spot, fascinated audiences at NASA's Jet Propulsion Lab. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly captured everyone's attention. Slightly larger than Earth's moon, Io turned out to be the most volcanically active body in our solar system. The spacecraft's instruments consistently detected volcanic activity, confirmed by dynamic pictures revealing volcanic plumes and a surface scarred by eruptions. One of Io's most significant volcanoes, Pele, erupted with a force typically greater than that of Mount Everest. Explorer 1 and Explorer 2 were not just ordinary spacecraft. They were the result of meticulous planning, rigorous design, and rotational speed much slower than the hour hand of a clock. This innovative engineering minimized apparent obscuring, allowing the spacecraft to capture simultaneous images and data as they traveled through space. Even before their encounters with the outer planets, their impressive imaging capabilities began to captivate both scientists and the public. The Explorer spacecraft began transmitting pictures of Jupiter long before completing their primary missions. These early pictures, showing swirling clouds and the famous Great Red Spot, fascinated audiences at NASA's Jet Propulsion Lab. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly captured everyone's attention. Slightly larger than Earth's moon, Io turned out to be the most volcanically active body in our solar system. The spacecraft's instruments consistently detected volcanic activity, confirmed by dynamic pictures revealing volcanic plumes and a surface scarred by eruptions. One of Io's most significant volcanoes, Pele, erupted with a force typically greater than that of Mount Everest, covering an area almost the size of France. Explorer 1's groundbreaking discoveries didn't stop there. After completing its close-up studies of Jupiter and its moons, the spacecraft went on to uncover more secrets of the solar system, pushing the boundaries of what we knew about the planets and their satellites. One of its major findings was in the far reaches of the outer solar system, where it captured extraordinary images of Saturn's rings and moons. The spacecraft's sensors, designed with a level of precision unseen before, revealed details of Saturn's environment that had eluded astronomers for centuries. It was through Explorer 1's eyes that humanity first began to comprehend the stunning complexity of this distant gas giant. As the years passed, the mission of both Explorer 1 and Explorer 2 evolved from planetary exploration to interstellar exploration. These spacecraft, designed to study the planets, were now sending back data from beyond the edge of the solar system. Their instruments continued to perform admirably, transmitting invaluable information about the environment of interstellar space. Explorer 1's ultimate journey took it into the vast expanse between the stars, a place so distant that it is beyond the influence of the sun's gravity. This marked a new chapter in humanity's exploration of space, as these missions showed that the desire to understand the cosmos does not end with the outer planets. These spacecraft were the pioneers of interstellar travel, pushing the limits of human understanding and providing a glimpse of what may lie ahead for future explorers. With each passing year, as the distance between Earth and Explorer 1 grew, so too did our knowledge of the universe. This invaluable data laid the foundation for many of the discoveries that would follow. Even as the spacecraft slowly faded from communication, their legacy continued to resonate within the scientific community. They are remembered not just as machines, but as milestones in the journey of human curiosity and exploration. The legacy of Explorer 1 and Explorer 2 has inspired countless missions that followed, propelling space exploration to new heights. The technological advancements that emerged from these missions, like improved imaging techniques, better communication systems, and more efficient energy sources, continue to benefit modern space programs. As we continue to launch missions to explore distant planets, moons, and even exoplanets, we carry forward the spirit of curiosity and discovery instilled by these trailblazing spacecraft. Explorer 1, despite its age and the distance it has traveled, still sends back occasional data, offering rare glimpses of the cosmic environment it now finds itself in. Its endurance is a testament to the ingenuity and foresight that went into its design, ensuring that it would continue to function long after its primary mission had ended. Even as new spacecraft take the lead in exploring the universe, Explorer 1's contributions are woven into the very fabric of modern space science. Meanwhile, the discovery of other extraordinary phenomena, such as dark matter, the expansion of the universe, and gravitational waves, has opened up new frontiers in cosmology. As we look toward the future, the scientific community remains engaged in deciphering the mysteries of the cosmos, building upon the foundation laid by early missions like Explorer 1 and Explorer 2. Each new discovery is a small step in an ongoing journey that began with those first missions sent into space nearly 5 decades ago. Explorer 1's final transmissions, now carried across the void, may one day be received by future generations of explorers. Whether these signals are interpreted as a message from humanity's past or simply as the last echoes of a long-forgotten spacecraft, they serve as a powerful reminder of our relentless pursuit of knowledge. With each breakthrough, we uncover new layers of understanding about the universe, and, in doing so, bring us closer to the ultimate truth that lies out there, waiting to be discovered.